Pour yourself a glass of water and look at it for a second. 2 out of every 3 atoms in there are hydrogen, the lightest, simplest atom there is. 1 proton, 1 electron, nothing else. And here is the thing you were probably never told. That same atom, the one filling your glass and floating through every cell in your body, is also the single most common kind of atom in the entire universe. The stars are mostly made of it. The sun over your head is not a ball of iron and rock like the ground under your feet. It is almost pure hydrogen gas, about 3/4 of it by weight. That is one of the most basic facts in all of science, and for almost all of human history, nobody knew it. Nobody. We looked up at the sky for thousands of years with no idea what it was made of. The person who finally figured it out was 24 years old. She did it in a thesis so good that a famous astronomer later called it the most brilliant ever written in her field. And when she first wrote down the answer, the most powerful astronomer alive read it and told her, flatly, that it was clearly impossible. So she crossed it out, not deleted it. She left the answer on the page, and underneath it she wrote that it was almost certainly not real. She was right. He was wrong. And for years, he got the credit. Her name was Cecilia Payne, later Cecilia Payne-Gaposchkin. Say it once because the odds are good you have never heard it, and that is the strange, quiet injustice at the center of this whole story. You have lived your entire life inside her discovery. Every time anyone tells you the sun is mostly hydrogen, every time a documentary says the universe is made of the lightest stuff there is, they are repeating what she worked out, alone as a young woman nobody in power wanted to listen to. So here is where we are going. I want to show you exactly how you weigh a star you can never touch, how you read what something is made of from nothing but its light, because it is genuinely one of the most beautiful tricks in science, and you can understand all of it. And then I want to show you how a discovery this enormous got hedged into a whisper, handed quietly to a man, and how the woman who made it spent the next 30 years doing the work of a professor while being paid and titled like an assistant. Let's start with a teenage girl in a lecture hall, the night her whole world changed. Before the stars, there was one evening in 1919. Cecilia was a teenager in England, sharp enough to win a scholarship to Cambridge, and at that point, she thought her future was in botany, in plants. Then she sat in on a lecture by a man named Arthur Eddington, fresh back from an expedition to watch a total eclipse of the sun. He had gone to the other side of the world to test an idea by an unknown German physicist named Einstein, the idea that gravity could bend starlight. And during the eclipse, with the sun blacked out, Eddington had measured the stars near its edge, shifting exactly as Einstein said they would. Sit with what that means for a moment. A man stood up in a room and announced that the universe had just been caught following a brand new rulebook, and that he had the measurements to prove it. Cecilia said afterward that her whole picture of the world was transformed, that she could have written the lecture out word for word. You have probably had one moment like that, where a door you did not know existed suddenly swings open, and you realize, that, I have to do that. For her, that was the night. She was done with plants. She was going to read the sky, but wanting it was not enough, because of where she was standing. Cecilia finished her studies at Cambridge and did the work, top to bottom, and Cambridge gave her nothing. Not a degree. In 1919, the University of Cambridge did not grant degrees to women, full stop, and it would not change that rule for almost 30 more years. Picture doing everything right, passing everything, earning it completely, and being handed an empty hand at the end purely because of what you were. So she did the only thing that gave her a real future. She left. She got on a ship and crossed the Atlantic to the United States, to the Harvard College Observatory, where a director named Harlow Shapley was willing to take a brilliant young woman and actually let her work. Think about the nerve of that. Leaving your whole country behind in your early 20s, on the bet that somewhere across an ocean, someone will finally let you do the thing you were built for. In 1925, Harvard awarded her a PhD. She is generally counted as the first person ever to earn a doctorate in astronomy there, and the thesis that earned it is the one that changed everything. To understand what she did, you have to see the strange and wonderful place she landed. Harvard had spent decades photographing the night sky onto glass plates, hundreds of thousands of them, and to make sense of that flood of data, they had hired a team of women to study them. They were paid almost nothing, and they were called, with no irony at all back then, the computers, because computing the sky was their job. And those women had built something extraordinary. One of them, Annie Jumpcannon, had personally classified the light of hundreds of thousands of stars into a sequence, sorting them by the patterns hidden in their light. Because here is the secret buried in starlight. When you spread a star's light out into a rainbow, it is not smooth, it is crossed by sharp dark lines like a barcode. And every chemical element makes its own unique set of lines, its own barcode, no two alike. Burn one element and you get one pattern, burn another and you get a completely different one. So in principle, The light from a star 1,000 trillion miles away carries a coded list of what it is made of. Cannon had sorted the barcodes. Cecilia was about to crack what they actually meant. Now here's the part that should surprise you. By the time Cecilia arrived, most astronomers thought the big question was basically settled. What are the stars made of? The reigning answer, backed by the most respected astronomer in America, a man named Norris Russell, was simple. The stars are made of pretty much the same stuff as the Earth. Iron, silicon, the familiar metals in roughly familiar amounts. The reasoning seemed sound. When you looked at the sun's barcode, the lines of iron and the metals were strong and obvious, and the lines of hydrogen were faint and thin. Strong iron lines, weak hydrogen lines. So, lots of iron, little hydrogen. The sun is basically a hot version of the ground you are standing on. It felt obvious. It felt finished. If you had been sitting in that room, you would almost certainly have believed it too. And it was wrong, in the deepest possible way, for a reason almost nobody had thought hard enough about. Cecilia was about to think hard about it. So let's actually do what she did, because you can follow every step. Start with the barcode. Look at this glass of water again. You will never travel to a star, never scoop up a piece of one, never run a single test tube of it through a lab. All you will ever get from a star is its light. That is the entire sample. The whole genius of this kind of astronomy is realizing that the light is enough. When light from inside a star pushes out through the cooler gas at its surface, the atoms in that gas absorb specific colors on the way through, the exact colors that element likes to swallow. Those missing colors show up as dark lines in the rainbow. Hydrogen punches its lines in one set of places. Iron, calcium, helium, each somewhere else. So the dark lines are a fingerprint left in the light itself. Read the fingerprint, and you know which elements are there. That part astronomers already understood. The trap was the next step. Everyone assumed a strong line meant a lot of that element, and a faint line meant a little. That single assumption is where the whole field had walked off a cliff. Here is the assumption, laid bare. Strong dark line, lots of that element. Faint line, not much of it. It sounds like pure common sense, and it is wrong, because of one thing nobody had fully reckoned with. Heat. A star is unbelievably hot, and how an atom responds to light depends enormously on how hot it is. An atom only carves its dark line into the rainbow if its electrons are sitting in just the right state to catch that exact color. And whether they are sitting right depends on the temperature. Crank the heat high enough and you can rip the electron clean off the atom altogether. Now the atom is broken open, ionized, and it cannot make its normal line at all. So picture hydrogen in a really hot star. There is a staggering amount of it there, but it is so hot that most of the hydrogen has had its electrons stripped away and the survivors are in the wrong state to absorb. The line goes faint, not because the hydrogen is scarce, but because the heat has silenced it. The faintness was never a head count. It was the temperature playing a trick on everyone reading the page, the same trick it would have played on you and me. So how do you undo the trick? You need a way to ask, at this temperature, what fraction of these atoms are even in a state to make their line? And just a few years earlier, an Indian physicist named Meghnad Saha had written down exactly that. His equation links the temperature of a gas to how ionized it is. How many of its atoms have been stripped of electrons? Saha gave you the correction factor. Feed in the temperature, and his math tells you how much of an element is hiding silently, broken open and unable to absorb for every atom you can actually see in the barcode. Here is the way to feel it. Imagine judging how crowded a stadium is by how loud it is. Sometimes the crowd is roaring, sometimes it is dead silent, and the silence does not mean the seats are empty. It might just mean nothing exciting is happening on the field. Saha's equation was the rule that finally told you how many people were actually in the seats, no matter how much noise they happened to be making. Cecilia took that equation, took Annie Cannon's sorted barcodes, and did something nobody had done properly before. She used the heat to correct the count. And the answer came back staggering when she corrected for temperature. When she finally counted the silent hydrogen along with the loud iron, the metals settled out at roughly Earth-like proportions, just as expected. But hydrogen and helium went straight off the chart. Not a little more, not twice as much. Hydrogen came out something like 1,000,000 times more abundant than the metals everyone had been counting. 1,000,000. The stars were not hot versions of the Earth at all. They were vast spheres of the lightest, simplest atom in existence, with everything else, all the iron and calcium and the stuff you are made of, reduced to a thin trace mixed in. The sun in your sky is about 3/4 hydrogen. The universe is mostly hydrogen. Look up at any star you have ever wished on, and you are staring at a ball of the same atom sitting in your glass of water. A 24-year-old had just read the basic recipe of every star in the sky, and the recipe was almost entirely one ingredient. This is one of the great results in the history of astronomy, and it was about to get hedged into an apology. Because before she published, the result went past Norris Russell, the most powerful astronomer in America, the very man whose Earth-like sun picture she had just demolished, and he told her it was clearly impossible. Now I want to be careful and fair here, because this is exactly the kind of story that gets flattened into a simple theft, and it was not that. Russell did not steal anything, and he did not order her to bury it. What happened is quieter and honestly sadder. He was the gatekeeper. He had the power to make or end a young scientist's career, and he was convinced she had to be wrong. So Cecilia, with everything riding on the goodwill of exactly these men, made a choice. In her thesis, she left the hydrogen result right there on the page, and beside it, she wrote that the value was almost certainly not real. She qualified her own correct answer to survive. Years later, she would say, "If you are sure of your facts, you should defend your position." She had been sure. And she had been talked out of saying so out loud. That is not the drama of a robbery. It is the slow, grinding cost of being right while powerless, and it is far more common than the robbery version we like to tell. If you have ever sat in a room knowing the right answer, while everyone with power was sure you were wrong, you already know the size of what she swallowed. Then comes the part that stings. About 4 years later, in 1929, Russell published his own work on what the stars are made of by a different method, and he reached her conclusion. Hydrogen, overwhelmingly. To his credit, he cited her. Overwhelmingly. To his credit, he cited her. He even wrote that the most important earlier work on this was hers. What he never did was admit that he was the one who had talked her out of saying it plainly in the first place. And because he was the towering name in the field, his paper landed with all the weight she had been denied. The discovery began drifting toward him. For decades, plenty of textbooks simply credited the composition of the stars to Russell, not through theft, but through gravity, the way credit always seems to roll downhill toward the famous. You have watched it move like that before, toward whoever already had the most of it to begin with. The young woman got there first, hedged under pressure, and watched the established man become the answer to the question she had solved. Even so, the people who actually read her thesis never forgot it. One leading astronomer called it the most brilliant doctoral thesis ever written in astronomy. The work was undeniable. The recognition was another 30-year fight. So what does Harvard do with the person who just read the recipe of the stars? It puts her to work, and it refuses to call her what she is. For years after the most brilliant thesis in the field, Cecilia held the title of technical assistant. Assistant. She taught courses, real Harvard courses, that for a long time were not even printed in the catalog, as if the classes she ran did not officially exist. She was paid a fraction of what her work was worth. One Harvard president is said to have declared that she should never have a position at the university as long as he was in charge. Picture being the most important scientist in your building and being labeled the help, doing a professor's job, training the next generation, publishing constantly, and being handed an assistant's title and an assistant's paycheck year after year after year. She did not quit. She kept observing, kept writing, kept teaching the students who would carry the field forward, and she waited out an institution that could not bring itself to say what she plainly was. It took an astonishingly long time for that to break. And then, in 1956, it finally broke. Harvard made Cecilia Payne-Gaposchkin a full professor. She became the first woman ever promoted to full professor through Harvard's Faculty of Arts and Sciences, and then the first woman to chair a department there, leading the astronomy department she had served for decades. After 30 years of being called an assistant, the title was real, and it was hers, and it set a precedent that opened the door for the women who came after her. If you have ever waited far too long for someone to finally call you what you already plainly were, she is your patron saint. There is one more twist, and it is almost too perfect. The highest honors in astronomy carry the names of the field's giants. In 1976, near the end of her life, Cecilia was given a major lifetime award, the Norris Russell Lectureship. It is named for the very man who had once told her that her greatest discovery was clearly impossible. She had outlasted the doubt, and she accepted an award bearing the name of the doubter. If there is any justice in this story, it is bent and late and shaped exactly like that. So pull back with me, all the way out. Cecilia Payne-Gaposchkin worked out what the stars are made of, not what the Earth is made of. Not a guess, the actual composition of almost everything there is, read from nothing but light, while the people in power were sure she was wrong. Let me be precise, because she deserves precision. She did not discover that the atoms in your body were forged inside stars, the calcium in your bones, the iron in your blood. That came later, from other scientists, building on top of her. What she did was lay the first stone. She is the one who first read what the stars themselves actually are. So look up the next time the sun is out, or pour that glass of water again and really look at it. Most of what is up there, and a great deal of what is in here, in you, is the lightest, oldest, simplest atom in the universe, and we know that because of her. That is the real shape of this injustice. Not that she was erased. Her thesis is legendary among the people who study this. It is that the whole world repeats her discovery every single day. The sun is mostly hydrogen, the universe is mostly hydrogen, and almost none of us can tell you the name of the woman who first proved it. Now you can. Her name was Cecilia Payne. If Cecilia's story got under your skin, do me a small favor. Like this video, subscribe to follow the rest of these, and tell me in the comments whose forgotten story I should draw next. There are so many of them still up there, waiting for someone to finally know their name.